Hello, Math 120, and this is Professor Gonzalez, and we're taking a look at the homework problems in HW 2.3. So what we're looking at here is functions, function notation, graphing different functions, like linear functions, quadratic functions, cubic functions, absolute value functions, and just kind of how the notation works when we're taking a look at f of x notation as it pertains to a graph, things like that. Okay, first of all, it says if, I'm reading right here, if g of negative 5 equals 2, then the point whose ordered pair is on this graph. Okay, so we want to get used to realizing that this part of the f of x or function notation, this is the input, which is going to be the x value. So if you see g of negative 5 is your x value. Then it says that it's equal to, now notice over here this notation, g of x is the y. G of x is the y. In fact, often when you graph functions, they'll put g of x right here, just kind of reminding you that g of x, the result of g of x is going to be your y value. So once we figured out what g of negative 5 is, its partner or its ordered pair is its y value of 2. So g of negative 5 is going to be the same thing as the y value when, same thing as the y value when x equals negative 5. Okay? All right, so next up we're going to graph this linear function. We should be getting pretty good at this. We've been doing this quite a bit in the last section. The very first thing you want to do when you're graphing is you want to, well, first of all, remember that this is in slope-intercept form, and slope-intercept form is the same when it's in function notation. F of x equals mx plus b. This is where the b value, right, is the y-intercept. That's our starting place. So there's our b value, which is our y-intercept. The location the graph crosses the y-axis is at positive 2, so we'll go ahead and graph that. There it is right there. And then we have the value that's in front of, the coefficient in front of the x is called the slope. Now this is a negative slope, and it'd probably be good to write this as a fraction, because it makes it easier for us to understand how it steps, how to step it, right? We do know a point to start at, and that was our y-intercept right there at 2. But this goes, because of the negative, how does it step out or slope out? Down 3, right 1. So from the starting point, we're going to go down 1, 2, 3, right 1. And 1, 2, 3, right 1. And so on, right? We already have enough information to go ahead and make our line. Try to make it as accurate as I can. Hope it's not snapping too. What happened to that little feature? Is that feature off? Let me just see something. Try that again. There we go. Okay, so there's the line. You saw how I made it, right? I started with my y-intercept. And then I used my slope, down 3, right 1, to create more points. There it is. Let's take a look at another graph. Now, you want to start getting good at realizing that this previous graph up here, I'll go ahead and highlight with pink, I guess. It had x to the first power, and of course this is y, f of x, or y to the first power, but in function notation it's just as f of x. So you realize that x is to the first power, which means this is going to be linear, and linear means line. Now this next one, you see a square. The x term is squared, and this is going to be quadratic, but it's going to make a parabola. which means it's either going to be opening as a u up or it's going to be opening down as a u. So when you do this problem, something to realize is that these parabolas will always have symmetry. Oh, that color never works right. They always have symmetry, meaning you can always fold them right down this vertical line of symmetry. And that just means there's always going to be some partnering pair points, which makes it kind of predictable. But also, when you see that x squared, you know it's going to make this parabola. So you already kind of know it's this U-shaped kind of deal. Very often when you don't know what a graph, exactly where it goes, and you're just getting used to it, you just plot some points. So we're going to plot some points. And a common point to plot, people like to plot, I guess, is 0 because it's easy to work with. And if we look at this function, f of 0, remember the rule is right here, equals my input squared minus 10. You can see where I got that, right? Input squared minus 10. What's our input here? Our input here is 0. So we replace a 0 there. And 0 squared is 0. And so this outcome is going to be negative 10. So we've got our first point, 0, negative 10. 8, 9, 10. There it is right there. Okay, let's take a look at another point. Now, I already know what this thing looks like just because I've done so many. So let me just take some points I might not take. How about 2? And so, of course, you put a 2 in. You replace the x with 2. And you get 4 minus 10, which is negative 6. So 2, negative 6. Boy, this is a small graph. Let me zoom in a little bit. 2, negative 4, 5, 6. It's going to be right there. Okay. Let's pick something else. Now, you see we know it makes a U. We don't know if it's opening down or up yet. I have a point here, and then I've got a point to the right. Let's go ahead and pick a negative value. How about negative 3? So if we pick negative 3, and of course we input that in for x, minus 10, so it's negative 3 squared. That gives us 9 minus 10, which equals what? Negative 1? 9 minus 10 is negative 1, so negative 3, negative 1. Let me zoom in, negative 3, down 1. And so that is looking like that could be some sort of, it looks like it could be a U shape, right? Now, if, and we don't really know for sure, but if this is the line of symmetry at this point, we don't know. If this is where the line of symmetry is, meaning if I folded the parabola on that line, the right side would land on the left side. If that's true, then we, now when you graph this, by the way, you're going to graph 3 points using MyLab. And you basically want to just plot 3 points and you'll start to see the U shape. It kind of figures out based on those 3 points. You have to click on the parabola tool and then you plot the 3 points. So, but what you don't want to do, and I haven't really tried it this way, but I don't think you want to plot the left point, the right point, and then the middle point. I think you want to be kind of consistent, but you kind of play around with that. It has directions in yellow as you're doing it. But this looks like a parabola that's opening up. Let's go ahead and pick, what happens if we pick, how do we pick negative 2? Because let me put a little color in yellow to predict. If this was actually, this red dotted line was a line of symmetry, well then, it means if I go right 2 and up 4, I've got a point. Well, if that is the line of symmetry, then that means going left 2, there should be this matching point. And I don't know if this is the line of symmetry, but if I get a matching point there, I know that, yeah, this is definitely the line of symmetry. So how about if we put in this point right here, which is negative 2. Let's try negative 2. Try negative 2. Use a color you can see. Try negative 2. Okay, so this is f of negative 2. So we replace the x with negative 2 squared minus 10. Negative 2 times negative 2 is positive 4. So we have to have this in parentheses. And we get 4 minus 10 gives us a negative 6. So negative 2, negative 6. Now let's zoom in. Did that actually give us its matching pair? Negative 1, 2, and then go down 1, 2, 3, 4, 5, 6. Yeah, definitely. This is definitely a parabola, which we already knew, but it's centered this way where we know that the line of symmetry, you can see from off this line of symmetry, you can see that we've got 1, 2 makes a point, 1, 2 makes a point. In fact, you can now know for sure if I'm on my line of symmetry and I go left 1, 2, 3 and have a point, which we found, then we know there's going to be a match. 1, 2, 3. There's a point over here. Okay, so that's one of the nice things about parabolas, that they're nice and symmetrical. Let's see if I can make a nice, finish up with a nice sketch here. There's my, wow, it's getting a lot darker all of a sudden. And the trick about this parabola, which I'm kind of blowing a little bit, is to try not to make it look like a V, which means when you come down here, you've got to kind of swoop in a little better, like I did not do. Let me try to fix this a little bit, making it swoop in a little bit better, making it have a curve to it, which gives it that parabola look. So it kind of has to go like this. Okay, so there is my parabola, okay? When you actually graph it, having that many points is awesome for a checkpoint, but with MyLab, I think you only need 3 points to graph that parabola. Let's take a look at the next question. And the next function is called an absolute value function. Let me write that right here. Let's see, I think I'll write it right here, absolute value function. That's the name. What does it make? Well, you want to get really solid in knowing that whenever you see an x to the first power, whenever you see an x to the first power, which there it is, and you see absolute values, well, that is a for sure sign that this is going to make a V-shaped graph that opens up, or V-shaped opening down. So, change that. So the thing, how does this work? Well, my advice to you when you're doing this is, so let me go back there. This is x. This is f of x. My advice to you is to try to put a value in for x that'll make that whole expression 0. What value for x will make this expression before you take the absolute value 0? And that is going to be a negative 8. Because that's always a good starting point for these absolute value functions, is what makes that value inside the absolute value 0. Now, absolute value, remember, just as a side note, what is absolute value? Absolute value, physically, it means how far is a number from 0. So if someone said, what's the absolute value of 1, 2, 3, let's say, what's the absolute value of 3? Well, physically, how far is 3 from 0? It is physically 1, 2, 3 away, so the absolute value of 3 is 3. And the other way, right, if we go up here, 1, 2, 3, 4, negative 4, well, how far, so if I say, what's the absolute value of negative 4? And absolute values are really good with distances, because distances, you don't have negative values. So I think that's maybe where it kind of came from. But how far is negative 4 from 0? Well, how far is it away from 0? It's 4. So that's why the absolute value of negative 4 is 4. But people think it's just, all you do is just get rid of the negative sign. And it's not really as simple as that, although it works for some of the time. But if you had something like, how about if you had x minus 5? People think you could just turn that subtraction symbol into a positive because it's absolute value, and that's not true. So if someone came along and said, oh, by the way, I want you to take that expression, and I'm going to tell you that x equals negative 2. So then you put a negative 2 in for x, and now you can't take the absolute value yet and call those positives. That will not work. But you have to do this operation first. What is negative 2 minus 5? Well, that's negative 7. absolute value of negative 7 is positive 7. So you have to have these basic arithmetic of how to add and subtract and simplify absolute values. Okay, so once you have that, then you come over here and we have our function f of negative 8 is going to be our input equals the absolute value, replace x with negative 8 plus 8. And we know negative 8 plus 8 is the absolute value of 0. How far is 0 from 0? Yeah, it's 0. So it's just 0. You don't change any signs or anything, of course. 0 doesn't have a sign. It's right in the middle. And so we have our first point, which is negative 8, comma 0 right here. So after you get that first point, the point that makes that absolute value expression 0, then I would recommend getting a point to the left and to the right. What students do at this point, sometimes what they'll do is they'll grab another point like what if they take negative 3, and then the problem is f of negative 3 equals the absolute value of negative 3 plus 8, and we know that's going to be the absolute value of 5, and the absolute value of 5 is 5. So they do that. They go to negative 3 up 5, which is right there. And they go, well, that looks like a line. Yeah, absolute values do have a linear quality to them, but it then bounces. It's not a line, right? So then the problem there is that they feel like they're going to convince themselves by maybe putting another point in like that. Let's put in 0. Absolute value of 0 plus 8 equals the absolute value of 8, which is 8. And then they feel like, okay, I am convinced that this is a line. So then they go like this. Right? Like that. And then they do the other side, and they call it a day. But that would be wrong. It's not a line. It's something you probably should have memorized. You see absolute value bars, and you should be thinking that is a V, okay? And I better look for more points. Now, the reason why I told you to make the expression inside the absolute value 0, because this is your vertex. Vertex is that turning point. So what we should have done, if we want to be super efficient, once we got this point and we got a point to the right, all we need to do is get one more point to the left. So what's to the left of negative 8? How about negative 10? So if I go to my function, I put in negative 10, and I put into my function negative 10 for x plus 8, well, that gives me an absolute value of negative 2, which equals 2. So I've got negative 10, and then now you can really see it. Negative 10 up to, yeah, this thing is bouncing back up, which that makes it, that is what's making it an absolute value, right? It's just making it a V. Okay, now when you graph this, I want to put a little note for when you graph it in MyLab. On the other points, you wouldn't have to have a specific first point, but whenever you're graphing, my pen is not working. Whenever you're graphing absolute value functions, and that's in MyLab, your first point must be the vertex. You must graph the vertex first. And the vertex is this point right there. That would be your first point to graph. And because when you're graphing in MyLab, you're selecting over here, of course, they got this little box that has a V on it, right? You're selecting that V, which is an absolute value graph. You really only needed to graph the first point, the vertex, and then a second point. And because it knows that this graph is symmetric about this point, then it can predict, right, with symmetry everything else. And so you only need actually to graph 2 points. First, the vertex, first point to graph, let me label that. First point to graph is the vertex. And then your second point is any other point on the absolute value graph, right or left. Moving right along here, use the given graph of the function to answer parts A through B. And we did this in the last problem, so this should feel somewhat similar. And remember, domain is the set of all x values. X values are left and right. Now you can see if I start here, I'm looking for all x values that are being utilized in this graph, and I can see it's for sure x values are here, they're going positive, and because of this arrow, this graph is going down and to the right forever. So we're going forever to the right, which is going to be positive infinity. That was a horrible infinity sign. It's still pretty bad. Positive infinity. And likewise, you can see we're going to the left, and then we're going down to the left, but it's still going to the left forever. That arrow says forever. And so we're going to the left forever. So really, the domain is all reals, and it says write it in interval notation. So you're just going to write it as negative infinity to positive infinity, and that is it. Now we want the range, and remember range happens to be the y values, which is up and down. Now, when you're doing interval notation, because they're asking us to write the answer in interval notation, you always write the smallest y value first and then the biggest. Okay, so if I start at 0 for y, you can see because of these arrows, it's going down forever, ever, ever. So this is going down to negative infinity. These are y values. How far does it go up to? And you can see it goes up to this y value right there, and that's it. And what is that y value? There it is, it's 8. So my interval notation would say, what's the smallest value on the interval? Well, it's negative infinity, and you can't close that or include it. The largest value is 8, and that is definitely included in my graph, so that must be with this bracket. What are the intercepts? Select the correct choice below, and if necessary, fill the box. Okay, so what are the intercepts? And the intercepts, they didn't just say x-intercepts, they said intercepts plural, and not just x-intercepts, y-intercepts as well. So I just need to list all my intercepts. Now, I would recommend that you take a look at this, the directions in the parenthesis. Type an ordered pair, use commas to separate the answers as needed. So that is important because it sometimes gets a little picky if you don't follow their advice there. So the intercepts are going to be, well, there's one right there, and that is negative 12. It said write it as ordered pair. So ordered pair is x comma y. So negative 12 comma 0. Separate your answers with parentheses. The next x-intercept is right there, which is positive 12 comma 0. And my y-intercept is this guy right here, where it crosses the y-axis, which is 0 comma 8. If you just put negative 12, 12, and 8, it would have marked you wrong because it said, please put it in ordered pairs. So sometimes those little details can be a little frustrating. Okay, we've got A through E to do. Yay. So this is the first of maybe 3 questions that's, I kind of hit it 3 times, but I'm trying to get you to understand function notation. And with function notation, what's going on here is basically what we're saying is, now this is f of x. Now this graph over here is the graph of f of x. They've not given us an equation, so we can't plug numbers into it. We can just look at the picture and try to pull out information. Remember, f of negative 5 is saying when x is negative 5, what's its y value pair, right? Well, when x is negative 5, I only see one x value that has a negative 5 on it, right? I don't see any other x values negative 5. What is its ordered pair? What's its y pair? 10. So f of negative 5, its ordered pair y value is 10. So f of negative 5 equals 10. And we're going to do the same, have the same kind of logic with this next one. When x is 2, so when x is 2, can you find a place where x is 2 on this graph? Yeah, right here. Is that the only place where x is 2? Yes, there's only one place where x is 2 on the graph. And its partner, or its f of x, or its f of 2, its y value is 3. Remember, function notation. f of 2 equals 3 is the same point as 2 comma 3. So we're just trying to drive that home. Okay, now what's the domain of the graph? And remember, the domain is going to be the set of all x values. And if I start at 0, this thing is going down, down, but it's still going to the right forever, so that means it goes forever to the right, positive infinity. This goes down and goes back up, but it's still going up to the left forever, so it's going forever to the left. That's negative infinity. So there is the domain. All reals, which is negative infinity to positive infinity. Be careful. It says please answer in interval notation, so that's why we had to use interval notation. And then let's go ahead and use, I guess, green for the range. Now range, remember, is y value, so if I start here, the range actually goes up and then it goes down forever, so it's going down forever, negative infinity. And if I start here, it goes down, but then it ends up going up forever. Well, that's bringing me to, or it doesn't get me there, but towards positive infinity. So the range is all reals, negative infinity to positive infinity. Okay, find the x intercepts. Select the correct choice below if necessary. Fill in the box, blah, blah, blah. It says to please, so I'm going to use another color here, just trying to keep our eyes looking at specifically what I'm talking about. It says x intercepts. Well, be careful. It says type an ordered pair answer. So x-intercept, what are the x-intercepts? Well, this graph crosses the x-axis right there. So the x-intercept, one of them at least, is -4. It said please write an ordered pair. So if you just put -4, it'll probably mark you wrong. You'll punch the computer and be upset. Another x-intercept where it crosses the x-axis is 0, 0. So there's 0, 0. And then the last x-intercept I see is right here, another place where it crosses the x-axis, and that's 3, 0. It said please separate your answers with commas, right? So that's how you write that. If you write it that way, it'll say fantastic and you'll feel really great about yourself. So there we go. There is the x-intercept. How about the y-intercept? I'm running out of color on this problem. How about, what can I use for the y-intercept? How about if I use this really dark blue? So how about the y-intercept? Where does this graph cross the y-axis? This is the y-axis right here. Where does it cross the y-axis? Well, it crosses right there. So because it crosses at the origin 0, 0, it happens to be the x-intercept and y-intercept. Right, so we're getting 2 for the price of 1 here. Please write it as an ordered pair, so the correct answer would be 0, 0. That really just looks like black, doesn't it? I don't know if we got anything out of that by using that color. Anyhow, and we're supposed to go ahead and mark A. And finally, for x equals what? F of x equals -8. Oh, this is the trickiest one of all, just for the last one. And I'm out of color. Yikes. Let's see. Let's go with that really greeny look. What this is saying, if I was going to put this in words, can you even see this? Yeah, I guess so, kind of. So if I was going to put this into words, when it says this, it's basically saying when y equals -8, what is the x partner, right? Or the x value that goes with it. So I want to go on my graph and look for when y equals -8. Where is -8? There is -8 right there. So y is -8. We want to know what x value goes with that. And you can see right there, 4. So when they say, if I can shrink this down, when they say, tell me what x is when f of x is -8, well, x is going to be 4. And remember, that just came from the point 4, -8. Okay. All right, let's continue on. Determine if the value is a 0 of the function. Now, remember, the 0 of the function is when the y value is 0, what is the x value? So the 0 of a function is just the x-intercepts, okay? The 0 of the function is just the x-intercepts. The only sneaky thing there is when they write it as an x-intercept, they write it as an ordered pair, and when they write it as zeros, they just give you, it's just one number, the x value. So be careful on that. So on this one, determine if the value is 0, is a 0 of the function. We want to know is, I still got this funny color going on here. We want to know if 3 is a 0 of the function. Okay, let's get to the bottom of this. So here's my function. My function, I'm going to write it right here. F of x equals x squared minus 3 times x minus 1. Now, if this is a 0 of the function, first of all, 0 of function, well, that's when f of x must equal 0, right? Because we know zeros of functions are where y is equal to 0. So our f of x or our y equals 0. So we're going to replace the f of x with 0. Now, if this is the 0 of the function, it's going to make the left side equal the right side. So we're going to go ahead and then put that in for x. So I'm going to put in 3 for x here. Let me use my black pen. So I got 3 squared minus 3 times x, which is 3 minus 1. Of course, we're going to do our order of operations first. 3 squared is 9, and negative 3 times 3 is minus 9 minus 1. And we end up getting a negative 1 on the right, and we have this 0 on the left, so this is no. The answer is no. 3 is not a 0 of the function, because if 3 was a 0 of the function, it would make the left side and the right side both equal 0, okay? So that is not true. Let's move on to 8. Find the 0 of the function f whose graph is shown to the right. Remember, I just told you the 0 of the function is going to be the x-intercepts. Be careful because it says type an integer or a decimal. Use comma to separate as needed. It does not say to use an ordered pair. I suspect some people are getting frustrated because they're really getting the right answer, but their format's not right. So just be careful. So the 0 of this function is just going to be this x-intercept at negative 15. It says please use a comma to separate the answers, so I'm going to put a comma in there. And then it says positive 15 right here, right? Easy to kind of have a mental lapse and use ordered pair, but it will nail you on that, and you will soon find out. You got to write it as individual numbers when they're talking about zeros. When they're talking about intercepts, they'll want ordered pairs, and they tell you right there too, right? I could see how that can be, you can forget that, but they give you a clue in parentheses, so just look at the clue. Next problem is to graph this function. Well, x is to the first power. This is a linear function. Linear functions just make lines, and we love that because that means that this is the y-intercept. Y-intercept is just negative 5. So my starting point is down here at negative 5. And my slope, if I can get it to work, is 4. And I like to write slopes as fractions because it tells me how to step it up 4 and right 1. So from this starting point, I go up 1, 2, 3, 4 and right 1. That's all I really need. And I could snap that line real quick, but I'll go ahead and do one more. 1, 2, 3, 4, right 1. There it is. So let's go ahead and finish up by snapping a line. And we'll even go the other way just because we can. And there's your linear equation. Okay, so once again, you see, when you see an x squared, you should be thinking this thing is making a parabola that opens up or down, this U-shaped, not a V, but a U. So what you should do, is, we're going to have much better, faster techniques, and some people might already know faster techniques, and by by all means, use a faster technique. But right now, at this stage of the game in this book, they're asking us to plot points. And I was trying to show you that if you see the symmetry, if you could establish symmetry, it makes it very convincing which points to plot. But you can go ahead and just try. How about that easy point right there? So I'm going to put in a 0. That just means 0 squared minus 4 is just going to give me a -4. So there's 1 point right there, right? So -4 is right here. I don't know if that's the vertex or not. I do know it's a vertex because I know something about these graphs. But let's say we just don't know if it's a vertex or not. So we plot another point. Let's plot 1. So we plot 1. We put 1 into the function. And it says 1 squared minus 4. That's just going to be 1 minus 4 is a -3. So 1 comma -3. Boy, these points are really close to each other. 1 comma -3. Okay, why don't we pick something else? How about we pick something to the left? And right at this point, if I want to see if the line of symmetry is going right through this 0 comma 4, if I pick -1, and if I pick, let me just show you. If I pick -1 and it lands right there, yeah, that's perfectly symmetrical. And so I already know this is a parabola opening up, and I can predict a bunch of points real quick. But let's see what happens when we pick that point. Do we in fact get a -3 also? And you can see the nature of a parabola, the fact that you square the input, and if you square a positive or square a negative, you still get a positive. That's what's causing this to give us the same exact output as the other number. That's why when I put in a positive 1, I got -3. And when I put in a negative 1 right here, I still get a -3, right? Which helps me to see how this graph is going to go. Let me go ahead and put another, because those points are so darn close to each other. Let me put one more point. That's all you need, actually, 3 points to do this in my lab. But let me go ahead and get another point. How about 2? And if I put in a 2 for x, remember the function says to square the input -4. 2 squared is 4 minus 4. That gives me 0. So when I take a look at this, I go to the right 2 comma 0. There's another point. And the fact that I've already established this symmetry because this is equidistant to that, I know that I can get another point. If that's 2 to the right, I can go 2 to the left, and I can predict another point. It's kind of 2 for the price of 1 with these parabolas. Anyhow, that point down there is a little bit big and sloppy, so let me just try that one again now that I've zoomed in. Let's see if I can make this thing nice and curvy. Like I said, the way you blow these graphs, and you're going to just be using the graphing tool on my lab, so you're a little spoiled that way, I guess. But you want to make it curvy, otherwise it looks like a V, and you don't want it to look like a V, because that's called an absolute value. Okay, that's getting a little bit sloppy, but you got me here. There we go. Curve, come on. The pen. If I zoom out, I think it'll look better. Yeah, maybe not. Oh, zoom out more. Oh yeah, now it's perfect. Okay, so that is done, and we take a look at our next graph. Hey, it's an absolute value. You see an absolute value, you know it's got to be a V. V opening up, V opening down. We'll try some numbers. What was my recommendation to you with an absolute value graph? My recommendation was that you should try to make this value, come on, work, this value inside the absolute value bars, try to make that 0. What is going to make that 0? Well, a -7 is going to make that 0. So I'm going to put a -7 in. I'm going to put a -7. What is the function? The function is f, oh, this is not the color I want. The function is f of -7 equals the absolute value of x plus 7. So now go ahead and use this color. My input is -7 for my x value, and it replaces the x value. And you can see that first we have to do our operation. -7 plus 7 is 0, and the absolute value of 0 is 0. So we get our point here at -7, 0 right there. And like I said, now with MyLab, you only need one more point because that is going to be the vertex. But if you didn't know that, and it's a good idea to kind of convince yourself. Let's pick a point to the right. How about, I don't know, negative, how about -3? -3, oops, I'm kind of running out of space because I think I'm going to erase some of that so I have some space to work here. So f of -3, and then I'm going to use my formula, which is absolute value of -3 plus 7. So now do that operation. The absolute value, so -3 plus 7 is going to give me 4, and the absolute value of 4 is 4. So I end up getting this -3, comma 4. So negative, let's zoom in, -1, 2, 3 right here, up 1, 2, 3, 4. So with MyLab, that would be it. As long as you clicked on the absolute value V button, you first do the vertex and then you got the other one. Well, another way to convince yourself of this symmetry, right? Another way, what color am I going to use? Let me use this just to kind of show a dotted line. If this is in fact the low point, the vertex, right, then that would mean that this problem would have to be symmetrical. So this is what I'm trying to predict. If I go from the vertical line of symmetry and I go right 1, 2, 3, 4, then there better be a point at 1, 2, 3, 4 to the left. And so we could just verify that if we really want to know if this is the line of symmetry and then that is the vertex, then what we should do is put in this x value right here, which is, what is that x value? -11. Why don't we put -11 in and see what happens if it actually gives us a +4. So this is not required, but it's good for learning. -11. So we put in so we put in -11 for x plus 7. So what is -11 plus 7? That's -4. And the absolute value of -4 is 4. And you can see that absolute value is doing something that the squaring in parabolas did. And it's making the graph pop back up because it's turning this negative into a positive. Oh, that's great to do in life, but that's what's happening in this problem too. So we've got -11, comma 4. So we got -11 up 1, 2, 3, 4, and for sure we know now that yep, this thing is absolutely, this absolute value is absolutely gonna have a vertex of that point right there. That vertex is -7, comma 0. All right, let's keep her going here. So graph, cubic. Oh, okay. So whenever you see a cube with the x, right, that is going to mean that the graph is going to have an inflection or this kind of look to it. Now there can be a little more to it than that, but that is the basic look to it. Let's take our time on this one because this one is a little unusual, but just knowing that it does that can help you. So you do want to kind of memorize that. Let's go ahead and let's see if we can get a bunch of values over here. Of course, this is h of x. H of x says, what do we do with h of x? Cube the input and add 5. So I don't know, let me try an easy number like 0. Cube the input and add 5. Well, cubing, so 0 cubed is 0. That's just going to give me 5. So I plot that point, 0, comma 5. Okay, let's get another point. What if we go to the right of that? Let's go, how about if we put in, let's put in a 1. So remember the rule, h of x rule says to cube the input and add 5. Now, if there was a negative here, you really would want to put a parenthesis. We'd luck out. It wouldn't make a difference on this problem, but on some problems it does make a difference. But anyhow, 1 cubed, gives us 1, plus 5 gives us 6. So 1 comma 6, 1 comma up 6, 4, 5, 6. So far, this is kind of looking, it's kind of, well, let's do another one. Oops. Okay. So far, let's put in another point like 2. Now you will find out this function, oops, you know what, I got to be technical here. It says it's h of x, so I'm going to go back and make h's there. It really wouldn't have made a difference in my graph, but should show proper form here. This is h of x. Now you'll find out, remember, this h of x function says to cube the input plus 5. You're going to find out that cubing numbers, they grow fast. 2 cubed is 2 times 2 times 2 times 2, which gives me 8 plus 5, which gives me 13. So that grew real fast. So if I go to 2 comma 13, there's 2. Got to go up to 13, which is right there. So at this point in time, when we go to graph this thing, from this perspective, it kind of looks like a very fast-growing parabola. I mean, you could have parabolas that are growing fast, so it kind of could have that look, like it's a quick-growing parabola. But something happens, though. You make sure you can see that point, and that point, and that point. Let's see what happens when we put something to the left of this. Now, if this was a parabola, we would expect a point right there. But it's not a parabola because it is cubed, not second power. Let's find a point to the left of this bottom point so far. How about if we put in a -1? So now we're going to put in a negative, oh, there I go. Back to the, can't help myself. F of x, F is the most common way to say a function. But F, G, and H are the most common. F is the most common out of those three. Anyways, so H of -1. So what does H function say to do? It says to cube it and add 5. Now, when you cube a -1, a -1 times -1 times -1, it actually stays -1. So the value of that is 4. So it turns out -1 comma 4. It actually did not bounce up. This is different. Now, this is what the cubic is doing, right? Cubic doesn't make negatives into positives like squares do, so it's not going to make this bouncing effect or reflecting up. Let's see. Let's put one more in. How about -2, just to kind of really drive it home. If I put -2 into this function that says, what do you do the input? You cube it and you add 5. Well, -2 cubed is -2 times -2 times -2. That makes -8. And -8 plus 5 is -3. So we just got -2, -3. So -2, -1, 2, 3. And so now you can definitely see that this is having a different look than a parabola for sure. It's called a cubic. And it looks like that. And by the way, this little point has a name. It's called an inflection. Inflection point. Inflection points in the business world, in one area, is really important because, when we're looking at the stock market, now it'd be the other way, but if we were looking at the stock market, and we saw something, I know I'm going in reverse, but we saw it going down, 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 down. Everybody says, buy low, sell high. So what if it was going down like this and someone got to this point right here and they said, ooh, it's a parabola. I'm buying right now because now it's going to shoot up. If you can tell that it's an inflection point, you'd say, no, I'm not going to buy. The world is ending. The stock market is crashing down, down, down. And so these inflection points can be misunderstood as vertex or vertices, which would be a different direction. You don't have to worry about the business application. But if you know me, I like money, so I like to talk about money. So anyways, let's move on. The next one, 13. Yes, I like money. Why did I start teaching high school? Because high school teachers don't make a ton of money. I love the kids, but then I only lasted 8 years to start teaching college because college students are really where it's at. So, anyways, number 13. 13 says for the graph of a function shown at the right, you want to find A, the domain, and the range, and the intercepts, and all this stuff. Okay, let's get to it. So could they make this thing any smaller? I don't know. Anyways, first question, we want to find the domain. All right, I guess red was my domain, so I'll start with red. Remember, domain is the x's and y's. Also be careful, it says write your answer in interval notation. You can see this graph is going from 0 here and forever up and forever to the right. That is going to positive infinity, and it's going down, but then it's going up forever to the left, whichever to the left is negative infinity. That's all reals. So this is just going to go from negative infinity to positive infinity. Remember, these infinity symbols are on the keypad within MyLab that you got to use. Range, I guess I'll use green just since I did it before. Range are your y values. And when I look at this, I'm looking at my smallest y value. And my smallest y value is right there on this graph, right, on the parabola, which is represented, there it is, -3. So -3 is my smallest y value, and then it goes up forever, positive infinity. So there is my range. Now is definitely including -3 because they made that a solid point, right? So it's definitely, -3 is inclusive. You got to make a bracket. So it goes from -3 up to positive infinity. Find the x-intercepts. Select the correct answer choice below. They're going to remind you, I think, don't be careful because I think you're going to get mad and hit your computer. It says type the ordered pair. Okay, get the x-intercept, type the ordered pair. Okay, need another color. Okay, my x-intercepts, I see 2. I see 1 right here. Type the ordered pair. Ordered pair would be -6, 0. It says please use the comma in between the answers. Boom, comma. What's another x-intercept? There it is right there. Type the ordered pair, 2, 0. Parentheses. And you're done. A, you have 2 x-intercepts and we listed them for you. Find the y-intercepts, intercept singular or plural. Let's see. Y-intercept, we'll do that in purple. Y-intercept is where this graph crosses the y-axis, and this graph comes down, 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 and it crosses right there. Oh yeah, okay, right there. I think I'm going to use another color. What will really jump out here? I already used green for that. I guess blue, but I think I need to get rid of some of this stuff because that is my y-intercept. Ooh, I see a mistake now. Okay, I see a mistake, and I'm gonna try not to use excuses, but this is pretty dang small. Let's see, let's zoom in. And this point right here, this green, actually is a -4. 1, 2, 3, 4. It's a -4. So when we did the range, that should have been a -4. How many people were just itching, waiting for me to catch it? You would have loved to be in class. Students love to correct the teacher. They just feel so great. It makes me feel horrible. And it's a win-win for everybody. This is -4. So this range goes from -4 to positive infinity. Okay, so the x-intercepts, we got that. Now we're trying to find the y-intercept. Now I'm doing the y-intercept. I guess I was doing it in purple. Now I can because I've got the other thing straightened out. That's my y-intercept. It's where it's crossing this y-axis, and the y-intercept is right there. Be careful. What does it say to do? It says the y-intercept, type an ordered pair, and there's only one ordered pair, 0, -3 is my y-intercept. There it is right there. It's where the graph is crossing the y-axis. What else do we have? Okay. Next, determine the zeros of the function, if any. Select the correct choice below. Okay, and it says make sure you do what? Make sure to type an integer or decimal answer. No ordered pairs. Remember, zeros are the same as the x-intercept, so I'll just go ahead and use that same color. So my zeros are just going to be the x values of the x-intercepts, and you can see them right there. The 0, how do you know it's a 0? Well, look at this. When x is -6, y is 0. That's why it's called the 0 of the function. When x is 2, y is 0. That's why that's another 0 of the function. But they also happen to be x-intercepts. But we're going to write it like this. -6, it says use a comma to separate. So -6, comma, 2. And do not put parentheses around it because then it starts looking like ordered pairs, right? All right, that is done. Is the whole thing done? Yes. Whew. Okay, next one. Got more of this stuff. Okay, I got 2 more of these kind of problems, but like I said, I think doing this, there's a lot of insight you gain about function notation when you look and man, this thing is really clustered. Look at that. Jeez. Okay. You know, when you do this on MyLab, I would definitely click on the magnifying glass or say enlarge the graph. I know you guys are much younger, and I used to have perfect vision. I'm just a little bit bitter about that. But anyways, I got to zoom in now. And I'm wearing glasses right now too. Anyhow, it says for the graph of the function shown to the right, find the domain of this graph. So once again, remember domain is x's and y's. And so when I look at this, this graph is going up and down, but really it's still going to the right forever. And it's going down and up, but it's still going to the left forever. So that would be all reals. Domain is going to be -infinity to +infinity open. Same kind of thing is going to happen. It's even easier to see on this one. This is going forever down, -infinity. And it's also going down, but then it's going forever with this arrow up. And that's +infinity. So that is also all reals, -infinity to +infinity. And it does say right in interval notation. Then we look for the x-intercepts. So our x-intercepts, remember, write the intercepts as ordered pairs. Your x-intercepts, there's one, -3, 0, comma. There's another one, if I can read that, -1, 0. And there's the last one, 4, 0, putting a comma in between each one of those and writing them as ordered pairs. So there are the x-intercepts. You know, at this time, if you want to list the zeros, remember the zeros are just going to be the x values of these x-intercepts. So the zeros are just going to be -3, -1, and 4. Okay, let's go to our y-intercepts. And singular or plural, well, there's just one of them. I think I'll highlight it with that guy. And I'm going to zoom in. That is just so hard to see the actual, I think it's 12. 5, 6, 7, 8, 9, 10, 11, 12. Oof. So it is 0, 12. That's the y-intercept. Just one value there, a 0, 12. Okay, we already did the zeros, and we're done. One more problem, and we're done. Whew, that was a run. Back to this. Okay, so what is this saying mathematically? It is saying when x is -28 on my graph, what is its y ordered pair partner? Find x equals -28. I'm going to have to zoom in. And I see x value is -28. That's the only x value that's -28. And so it's partnered up with -4. So f of -28 equals -4. Let's try another one. Now we're asking when x is -12, what is it partnered up with? And I see a -12 right here for x. And its y value is 6. So we would say f of -12 equals 6. See how many colors I have here to work with that work. Purple. When f equals 24. I'm sorry, let me say it again. When x equals 24. Is there only one value x of 24? Negative 20. Oh my gosh. Was that negative 24? Okay, let me fix it. Positive 24. Positive 24 is over here. What is it partnered with? 4. So we get f of 24 equals 4. Okay, so you could, hold that, take a picture, whatever, but I think I'm going to erase the color over here on the right so I can start using color again to answer some of these questions. Okay, now this one's a little bit tricky maybe. This one says f of 8. Is f of 8 positive or negative? Well, what this is basically saying is saying when x is 8, is the y value positive or negative? So we got to go find out where x is 8. And I see x is 8 right there. Is the y value positive or negative? And it's definitely negative. So we would say, is f of 8 positive or negative? F of 8 is negative. Next question. Next color. For what numbers of x is f of x 0? So this is a little bit trickier, but remember this is saying when y equals 0, what is its x ordered pair? What is x? Go find when y equals 0. Actually, y equals 0 here, here, and here. So you're going to have 3 x values that go with an f of x equaling 0. When y equals 0, remember f of x is going to be the same as 0, right? I'm sorry, f of x is the same as y. So when y, if they say when f of x is 0, we're saying when is y 0? And when y is 0, what is its x ordered pairs? And we've got 3 of them. So use a comma to separate your answers as needed. They're just asking for the x coordinate. You're definitely not going to write an ordered pair. And what's the first one? It is what? Negative 24, 4, and 16. Negative 24, comma, 4, negative 4, and 16. What is the domain of f? Let's see if we can just look at this. Okay. Well, this doesn't have arrows on it. This changes everything. So the smallest x value that I see here, let me use another color since I've already used red. Let's use purple. The smallest x value I see is right there, and it comes from that point right there. So this, and it's inclusive, so this goes from negative 28 is the smallest x value all the way up to, right there it is right there, all the way up to the largest x value, which happens to be positive 24. And that is also inclusive because you see the solid dot. So negative 28 comma 24, and it's closed. Negative 28 comma 24, and it's closed. What is the range? Okay, the range, we will use that color. The smallest y value. So I see a negative 4 here, and I see a negative 4 there. So that's the same line. Sometimes that gets hard to see. So the smallest y value is negative 4, and it goes up to the largest. Well, I see a positive 4, but this one's bigger. This one's just a little bit higher. That's up to 6. We're talking about the y values because range, remember range are specifically the y values. So our range has to go, the smallest value is negative 4, closed, up to the biggest value, 6, open. I mean closed as well. So negative 4 to 6, closed. Next, what is or are the x-intercepts? Well, there are these guys in green, and x-intercepts is saying they'd like to write them. I think I'll use green there. And it says, please type the ordered pair. That means x comma y's. So it's just going to be negative 24 comma 0 comma negative 4 comma 0 comma 6. Is that 16? Double check. Yeah, right there. 16 comma 0. Okay, what is or are the y-intercepts? Now let's see the y-intercept, and there's only one. And I guess we could use hot pink for the y-intercept. Y-intercept, here's the y-axis. There's the y-intercepting point, and you can see that is 0 comma negative 2. That is 0 comma negative 2. For what number of x is f of x equal to negative 4? We are definitely running out of colors. What can I use? Guess I stay away from these others because I don't know if they're easy to see, but I'll try gray. This is saying, if I want to try to put that in words, this is saying when the y value is negative 4, what's x? So we go to look for, well, y is negative 4. And I see a y value of negative 4 here, and I see a y value of negative 4 again here. So there's going to be two places. That is, x is negative 28, and x is positive 8. Remember, use commas to separate your answers if needed. These are just x values. Don't make ordered pairs out of them. Negative 28 and 8. For what numbers of x is f of x 6? I'm really running out of colors now. I'll go with this bright color here. If I were trying to put this into words, it's saying when y is 6, what's x? Let's see if I could find where y is 6. I see y is 6 right here. In fact, that is a peak, right? So I'm not going to have any other y values that have even gotten that high. So when y is 6, x is negative 12. Okay, and it would have been nice if they stayed a little consistent. Like right here we said x equals and x equals, but they didn't do whatever. Next and final problem. What is or are the zeros of f? Well, the zeros are going to be the same as the x-intercepts, right? You can see them there in green. So let's just do this in green. Instead of being ordered pairs, they are, instead of, yes, if they're zeros, we're not going to write them as ordered pairs. They're going to be individual numbers separated with a comma. So it's negative 24, comma, negative 4, comma, 16. Remember, same as these. The zeros are the place on the graph where the y value is 0. So negative 24, y value 0. Negative 4, y value 0. 16, y value 0. There they are. They're the same as the x-intercepts other than ordered pair versus individual x values. Okay, that was kind of a long one, but hopefully you learned a lot from that and answered some questions and formatting on how to put things in and made life a little bit easier for you. I hope you have a great day. Take care. Bye.